right, perfect. We're live. Welcome, everyone. This is the fourth Flashwares session. This session will be hosted by Mateusz. Information about the session, as well as previous and upcoming sessions, can be found on the forum, collective.flashbots.net. And with that, I will hand it over to you, Mateusz.
All right. So, hello, everyone. I've prepared a very short presentation, 3 slides, and then I would like us to go and try to make something actually work on a bare metal TDX, and hopefully I can follow us at home, but also just feel free to comment with what you would want to do next within the context of TDX and virtualization. All right, so I'll go ahead and talk for like 10 minutes. All right, so yeah, the topic today is TEEception. So it's the idea of using TDX to run a attested hypervisor. So we are putting, we are putting containers into our VMs, and that's running in TDX. So why would that ever be a good idea, right? So that's the gist. That's the idea of today's Flashwares session. And it's more like a jam and like a hack session rather than me explaining anything or me teaching you something. I will be wrong a lot of the times in this presentation, so feel free to correct me. And hopefully I can also learn something new.
Sorry, one quick comment. Only half the screen is shared right now.
All right. Let's fix that. This should work.
No, still. I think you should turn off the share screen and turn it on again, probably.
Yeah, it's blocked. Okay. Stop share. Hopefully we can beat the share screen issues before we dive into solving all of crypto.
Perfect.
All right, does this work?
Much better.
Much better or like perfect?
Perfect.
Perfect.
Let's go. Perfect. Okay, so first, like very quickly, virtualization and containerization was the difference. I'm sure most people have at least heard of those terms, and at least some of us are, I'm sure, experts in the domain. So there's a couple of ways you can do virtualization. So why virtualization is nice is you're not running your applications with access to your hardware. So you can run something that you don't fully trust, or just as a security precaution. Think, for example, Firefox windows, right? You don't want your your Firefox windows to have access to your RAM, right, and to your disk, of course. So that's one example where you do trust somewhat the application, but as a precaution, you don't want to be running that. So that's like software containerization, and what we'll be doing here is hardware virtualization, at least in part. So hardware virtualization is where the whole thing is running in a sandbox, right? So the whole OS that you're running, rather than just a window, the whole thing is running without access to hardware, or at least direct access to hardware. And that, like one example would be like just full virtualization, where your OS, this green box, and your applications, they know they're in a sandbox, but they just can't do anything about it. And the only way for them to access hardware is through the hypervisor, through the host OS, right? Where the host is whatever is running your application in your virtualized OS. And yeah, so that's for virtualization. Some of the technologies that can do this is, like Xen, it's like an old thing. Nowadays, mostly like Camo and KVM. Can use those to emulate basically the whole machine, right? There's no access to the hardware directly. Then we have something in the middle where you have this green box, this guest OS, but it actually does have access directly to the hardware for some instructions, which makes it, for example, much faster, right? Because you don't actually have this emulation layer. This is called para-virtualization sometimes. And there's things in the middle. Like if you're using like Camo and KVM, it's not true that it's like in either of those, right? You're using basic KVM. The KVM is like a kernel module for virtualization, right? Kernel virtualization module probably. And you're, although I'm not sure that's the right abbreviation. And you're using that as a way to accelerate your application, right? So some of this actually is translated much faster, and some of your workloads actually run on the hardware. So there's like not a very even split, but there's like things in the middle. And then on the far left, we have containerization, or sometimes also called OS level virtualization, where you don't even run an OS, right? It's just your application running somewhere with a bunch of libraries, and then you have some kind of engine underneath that's going to serve your application, basically OS calls. So here on the right side, whenever you want to go access hardware, you're going to exit out of your VM and go ask the hypervisor or the hostess or whatever to give you access to hardware or to do something with the hardware for you. With containers, that's not so much, right? You just request the OS, like with an OS call, and that goes into the container engine and gets translated into whatever instructions. So it's a bit high level, and if we think about security, full virtualization is kind of the most secure because nothing ever really runs on the hardware. It's it could be the strongest sandbox. I'm not sure if it is because there's still things that can go wrong, and you can probably escape this green box of your sandbox, right? This green is the sandbox, and you can try to escape to your host OS by leveraging some kind of attacks against this virtualization that you're under. So with a container, the problem is that you have access basically to the host kernel. So if you think about it, like your app goes and requests something from the OS, what happens there is it goes into the kernel, right? So if there's a bug in the kernel, or if there's a bug in the host OS, or if there's a bug in the container engine, you basically immediately get permission and get access to the hardware. So if you run, for example, if this blue box is, for example, previous Docker container, right? It's like kind of trivial to escape it because you have access to all the devices of the machine. So this is like usually kind of easy to escape. And there's some options of some container engines that are simply insecure. This para-virtualization is kind of a bit more interesting because there's the attacks are maybe less obvious because there's no host OS to escape to, right? It's just the hardware. Right, but I'll stop now. Are there any questions? Did I get something wrong, by the way? Like, please do correct me.
I do have a comment here. So I think when you mentioned the full virtualization with QEMU and KVM is probably the most secure, there are people who say differently. I don't know if you heard about the Cubes project, the Cubes OS project, and I can't remember the details right now, but they try to ditch KVM and QEMU for Xen, and the idea basically is they view as hardware-based isolation as the most secure of all. And then comes software-based virtualization, which is what QEMU does. It's an emulator, right? Obviously, like hardware-based isolation is most likely more secure rather than any kind of software written code that might contain any kind of bugs or something like that. Of course, we have hardware bugs as well, but they seem to be less common than software bugs. That's just my comment here.
Yeah, I think that's right. So this approach with para-virtualization, where you don't even have this host OS to escape to, right? And there's no emulation that you want to try to find bugs in. Yeah, could be more secure. I could definitely see that being a case. But I didn't do as much. This is a kind of intuitive, where full virtualization is for sure safer than containerization. Although again, with very good containerization, maybe it's secure enough. And yeah, it's para-virtualization where you kind of have direct access to hardware, so you can do some things. You can do some things in, if you're under para-virtualization, you can, for example, try to abuse the resources, right? And things like that, where it's not an escape, but you can still mess things up. But yeah.
I have also here, yeah, that's all true, but it's also very use case specific, because para-virtualization, if I recall correctly, for scenarios where you are trying to virtualize a process for a different architecture, then it will not be your target, and then there you only have the option of full virtualization in this case, or maybe containerization, where you can, yeah, maybe specify a different target, but I don't think para-virtualization will help you here.
Yeah, absolutely, because you're running on top of hardware.
Yes.
You must, the target must be the right hardware.
Exactly.
You can do a trick here. You can actually run this. You can run emulation here, right? So rather than treating the emulator, which is, Camo is an emulator, right?
Yes.
Rather than treating Camo as a virtualization, like for sandboxing, you can treat it for just emulation, run Camo here, and then whatever else you want on top of that.
Yes, that's true. But then you have to provide this manually, because
and then it's very slow, right? Because Camo with KVM is kind of fast here. If you're especially if you match the hardware, if the hardware is the same as the Camo target, as the Camo guest, is very fast with acceleration. Here is gonna be it's gonna be slow by definition, because the guest OS is a different target than the hardware, so you have to emulate.
Correct.
Okay. Let's get into the meat, which is TDX. So, why am I going on about this virtualization? Because TDX is is a virtualization thing, right? It's it basically looks like this, right? The trusted domains, right? I think of it as VMs. It's probably incorrect, but that's roughly the idea. So I think that this is how it looks like. This is like an artist, this on the right is my rendition, artist rendition of the thing that Intel provides in their docs, where we basically have this addition of this TGX module, right? That's doing something. That's living basically on top of the hardware, right? So and this I think is true, because the TDX module does access the hardware directly for some instructions at least, right? So Frieder, actually, feel free to correct me if you know, because I think that the TGX module goes and talks with the hardware directly, right? Or rather, the hardware keeps track on behalf of the TDX module. All right. So there's going to be some trusted domains running, basically a guest OS, right? So this is a full VM. This is not a container. It's actually running an OS. It's like some asterisks. What kind of OS is that? But it's going to be the OS. And on top of that, you have whatever you'd put on top of your OS, right? Whatever drivers you have, whatever applications you have. And then that goes and talks to either the hypervisor or the TDX module, or the hardware through the TDX module. So that's kind of cool, right? Like we have this box. I think that's roughly how we can interpret it when it comes to in this context of virtualization. And I'll stop here for a bit. I would love Frieder's opinion about my rendition of this diagram.
I mean, I think the interesting thing about TDX here is that and you can see this here in the picture very clearly. It's trying to not only wall off different VMs, being able to extract information from each other, but the actual host and platform itself, and it does so via the TDX module. If we want to interpret this picture, of course, I'm not a TDX module expert, but it does provide some interface to the VMM, and does take a lot of responsibilities that a normal VMM actually has. Like example, if you could look at the nested page tables or extended page tables, it's taking care of that. Although we've learned that it's not like if you look at, for example, migrating the VM to a different host, and there's some exceptions, and we're still not sure whether these are secure or not. But in essence, the idea is that the TDX module has access to the extended page tables and the host VMM not. And so yeah, there's quite a lot of isolation happening, and this is good. And also good is that this TDX module is software, and it can easily be upgraded, even though you don't have to reboot your system. You can do it on the fly, and then that will be part of the attestation as well. So far so good. What we've seen from Intel, this makes sense. Unfortunately, if you go into the details about memory access and stuff like that, either things haven't been figured out yet by us, or there needs to be some additional work here. But it looks like that the TDX module is, as it is software, we can change it, and we can provide suggestions how to change that and make it more secure to provide our needs, where we want a TD VM running without ever getting interrupted, and like making this wall perfect that you see here. That's basically just running like it's running on a different CPU, and the host really doesn't have any kind of access. And if it tries to access any kind of page table information, then yeah, whatever, like our application gets slashed or will stop, something like that.
All right. Yeah, there you have it. Yeah, this does look good, and this does look like an improvement from the user perspective. Like if you want to go and run this in a cloud, right? Like if you're a user and this is like your OS, you want to go and run your application. This does give you separation from the cloud, basically, right, from the cloud hypervisor, and shields you from them accessing anything here, which is very nice. All right, cool. I can see, okay, so KVM stands for kernel-based virtual machine. Of course it does. And then can I talk about preferences about LXC and Docker? So to me, the level at which I'm kind of thinking about this is what kind of virtualization we want. So to me, Docker and LXC and Pullman, gvisor, whatever else, sits kind of in one bucket, and it kind of depends on which one fits your needs better, right? Like for you specifically, like what do you want of this? Do you want to be running untrusted code in that containers, like on behalf of people? Probably don't use Docker. Probably don't use LXC either, actually, right? Yeah, and if you don't care, if you just prefer LXC, then go with that, right? Yeah, at that point, it's like whichever tool fits you best. But as far as the virtualization goes, and as far as TDX goes too, it's actually kind of the same. Hopefully that answers. All right, so this is what TDX looks like if you think about it as like a part of the virtualization stack, basically, right? It's a module that's translating to the host VMM. I'm gonna continue calling that the hypervisor, though it's not the hypervisor, but whatever. And some of this to hardware referred has the extended pages table, right? So there's some things residing here. Some things are delegated to the hypervisor. All right, sweet. So why I'm excited about this, right? So why I'm excited about this is that we can also run containerization here, right? We can nest this container because this runs just in regular OS. We can do another level of virtualization, and with a proper sandbox, you can probably run untrusted code in those trust domains, right? Where whoever gave it the code can be convinced that you're not going to do anything to the code, and there's not much you can do with the hardware to kind of trick them. And as long as you control the sandbox and set up properly, it could be safe as well, depending on what type of virtualization you are doing. But why I'm even more excited is that you can run containerization here inside this green box. So you have this TDX module that's acting as everything in this blue box can be attested, right? You can go and attest everything here, and in particular, if you're doing, for example, OS level virtualization, like Docker or something as the guest, you can actually attest that you're doing this correctly or according to some rules, which I find an interesting topic, and hence the TEEception, right? We're going to run some sort of containerization solution or virtualization as a guest of the TDX module, and we'll see where that gets us, right? So, for example, can you attest anything, something that runs as the guest, right? Let's try to find out. So, yes, that's roughly what I'm talking about. So, I think that TDX and nested virtualization is something worth exploring, and it's definitely something that that's worth hacking on. This is kind of simple to set up. You'll see that it takes maybe an hour to get up to speed on this and start using a stack like this. And yeah, so with like an OS of a virtualization, so like Docker, this would look like this thing on the left, where we have the TX module and the guest and the container engine all attested, right? So this blue box. This blue box is attested. The green box is not necessarily. Let's talk about it later. Yeah, but you can attest all the rules that are going on in this blue box. In particular, how you run the applications with the container engine. What kind of version of the containers are you using? Right? What's the firmware? What commands exactly are you using? How are you sandboxing? Right? Like, are you running this privileged containers, or are you running user space containers or whatever? And on the right, this would be like a full virtualization, where probably not like full virtualization with an asterisk, probably hardware accelerated so that it's fast. Where instead of a container engine, we're running another hypervisor, right? So we are running our own hypervisor. So this hypervisor, I'm not sure if you can attest. I don't think so, right? I think this is trusted. But we can attest this other hypervisor, which I think could be pretty neat. I would like us to explore if this gets anywhere, and if this is useful at all. All right. Questions? That's it for the presentation. So let's take any questions that people may have. All right, no questions. Everything is clear. Let's go. Right. So that's it for my presentation. As promised, very short. And yeah, let's try to figure out like what do we want to do as next step. So I have some proposals. I have some agenda. What I thought would be nice to do is just go and look at how this looks like. How do you actually run, Docker inside Camel inside the TDX VM, right? I don't think that's it's kind of straightforward, but it's maybe counterintuitive. So it's good to see that actually works, and that you can still access the attestations in particular from this nested container. I can show you where I'm stuck with nested full virtualization. because I'm actually stuck with running Camo in Camo. For whatever reason, the KVM module is just not available. We have some very cool things from Mo, who has recently built a Yocto image with Podman inside. So this would be like a reproducible image where you have a containerization solution inside the image that you can run as a part of a TDX VM, which I think is pretty cool. Yeah, I think that's it. So Leo is asking, is Docker itself reproducibly built? I actually have no idea. I'd be surprised if you couldn't get it to build reproducibly, but I didn't check. And I think that if it's not built reproducibly, you could probably always use something else. That's a good question. I actually don't know. If anyone cares to check, I'll also be very curious of the answer. All right. In the meanwhile, I'm going to set up my console, and let's see if I can run it. Let's see if I can run the Docker in Camo again, because I did try. Yeah, live demos, right? All right. I have to make it big. Right, so I have access to a bare metal instance, so this is very nice. So this is not a TDX VM as you would get from, let's say, Azure, right? So this is a bare metal server that is TDX enabled and that we've configured to work with attestations, right? So yeah, so we'll be using like we have access to all of the hardware, and we have access to all of the we have like TDX guest device, right, and things like that. Okay. So I have found the guide from Canonical to be an extremely useful resource. It's linked on the forum under it's just canonical/TDX. I'm also going to paste it in the Zoom if anyone wants to follow. So let's just make sure that I've set it up correctly. So they're asking first to go and let's just look at what the script does, right? Like how does setting up ITDX bare metal host look like? So first thing they ask you to do is to go here and run this setup TDX host script. Okay, let's go and see what this does. Okay, I have no idea what this does as some kind of boot options. Later on, we have this Cobok team, which is building like TDX libraries, and this is going to be actually very important. All right. I have a bunch of other dependencies. In particular, we are going to install Camo. Right, Camo system x86 is there's various flavors of Camo. This is the target that you want to emulate, basically. In this case, it's just going to be native, right? Because we are on a x86 server as well. And this TDX tools host, this is from the Cobok team, and this is where most of the goodies come from. So if you're interested in seeing the actual libraries and the actual tools, this is where you actually want to go. All right, so we're switching the kernel here, and that's it. Okay, so in Grub, so this is like the boot options. The thing that we are doing is we're allowing the KVM Intel TDX, right? So this is like enabling I think this enables the TDX device inside the KVM module, right? So that we can have access to TDX inside Camo VMs, and this is actually very important. Right. right? So this means that we'll be able to go and request quotes from inside the VM. Right. So here is just a bunch of dependencies. As you saw, this is not it's not very complex. The most complex change is probably enabling the KVM module and then configuring it with TDX support. All right. So a couple next steps. They ask the guide asks us to go and enable TDX in the host's BIOS, which we have done already. I'm not going to show you that. And yeah, let's see if our host is TDX has TDX enabled, and you can see that it indeed is. So if you're following at home with your own machine, this is kind of what you want, what you're interested in. Once you boot up, after setting up the host, right, this TDX module should be enabled. So both in BIOS, and then you should see the and you should see this KVM Intel being enabled here with TDX as well. All right. Next up is the guide is asking us to go and generate the VM image that you're supposed to run. So let's go see what this does. This is rather simple. So we're going to use a official Ubuntu image, right? Something like just like Ubuntu 23, right? And we are going to do a bunch of things to the image, making it like a TDX guest image ready to be run with Camo on our machine. So I'm not actually going to run this because this will take forever. This takes like an hour. I've run this earlier, so I already have the image. Yeah, what this does basically is goes and downloads the image. It's not very interesting, and yeah, then it's going to go and install. So this is kind of interesting. It's going to install the cloud init data. Right? It's going to install all of this, as like metadata. You're just setting up a bunch of stuff. And here's how we define how the image defines the dependencies that it was installed. And again, you see that the packages are kind of fine. It's the same. There's this. So this is the important bit, where we will mount the TDX device, right, in this like inner VM. Once it boots, it's going to go and mount this mode. You can like, if you need to, you can modify this. This could actually be important later on. You could make it a part of some group, right, so that it mounts with a non-root group. Could be useful. So yeah, this is important. It's going to mount the TDX devices, in particular the device that you're using to get TDX quotes right inside your VM. Right, and again, thanks to the Kobuk team, as you see, all of their tools. And yeah, the last thing is it just sets the root password to 1, 2, 3, 4, 5, 6. Right, I don't think there's anything more here. So let's go back. And yeah, the next thing it's gonna do is just going to increase the size of the image. So when you download the image, is very small, but you want like the disk of this VM to be bigger. And how you do that in Camo is just add space to the file, right, that you downloaded. Yeah, so this is how they do it. Yeah, here they are copying the user data. And they're doing some like image magic because what you download is an ISO and okay, whatever. This is, I don't think anything. I think the rest is kind of simple. Okay. So one thing that's important that's left is this setup TDX guest. They're going to copy it into the TMP of the VM, and then they're going to run it. Right. So this is kind of important. We should probably go take a look. And that's it. That's going to be the image. All right, let's go look at the start TDX guest. This is basically what makes the image, TDX, right? And it's very simple. All it does is installs a bunch of dependencies, again, from the Kobok team. Right, so they're adding the Red repository and installing the Kobok TDX guest package, which contains a bunch of stuff. In particular, it contains like tools to get the quotes, to get the TDX quotes. All right. So once you run the image, what you'll get out is this, TDX guest Ubuntu 23 with this QCOW2 format, which is the CAM format. And let's see. And yeah, the next step is just to boot it. So let's try. Let me see if I actually have the image running anywhere. Yeah, I do. So let me kill it. All right, and let's run it. So the run command is like a bash script, and then I'm exporting the path to the now created image. And let's take a look quickly at the command, at the script. So this is slightly modified. I'm trying to make it run with tested virtualization on with very success. Yes, the success is partial. Let's just say. Okay, let's see what it does. So first, the script checks that your user is in the KVM group, because otherwise you cannot use the acceleration or in general the KVM module, right? So it's important that you do. Then does basically nothing, right? It's just running the QEMU system. This is the native one, right? And you can see that it's the native one because we are passing in CPU host, right? So in QEMU terms, this means that the guest and the host is the same target, and we are asking QEMU to not emulate anything, right? Yeah, there's a bunch of things here. I didn't quite work out how the memory encryption is handled here. Yeah, so if anyone knows, that would be nice to learn about. Yeah, it's basically saying, please encrypt my memory with TDX, and I have no idea how that's handled inside QEMU. I'd be very curious to learn. All right, and then yeah, just does not much else really. And yeah, and just tells you that it's running. So let's go ahead and run it. All right. Usually needs a second to boot up, but all right, and we are in. Okay. And I'm looking at the guide. What else they're asking us to do, and yeah. So now comes the verification part. So first they're asking us to run this command, right? Mask pipe into grep, look for TDX, right? So we are going to look through the mask. So this is like the kernel log or something like that. Right, so first thing it does is it says that it's detected that it's a guest, which is very nice because it's also correct. And yeah, saying that it has like memory encryption with Intel TDX, which is nice. So this looks so good. Of course, this is not something that you can trust because it's just a log, right? So we actually need a better way to confirm that we are indeed in TDX. So the next thing that they ask us to do is check if the TDX guest device is mounted, and indeed it is, right? So this is where we go and request our quotes. And all right, I think that's it. So the guide goes into setting up attestations, which I'm not going to show because it's either very simple and you just follow the script, or very complex. We have followed the guide with hopefully success. And okay, next thing that they ask us to do is to go and set up the guests attestations. So here again, Kabuk team, the sleep TDX attest dev, I think this is from the Kabuk team, has a bunch of nice things. In particular, I think this is the thing that they provide. It's like an example quote, which we're going to go and run. So yeah, let's run this. And what's this gonna do is it's going to build this example that goes and requests a TDX quote. So generates like a TD report and requests a quote. I never remember the path. So okay, and then we can go and run it. And all right, so we have some bytes, right? We have some hex. And yeah, it's going to generate the report data. Here we have the full report. This includes all of the fields that we are looking for, probably like what image was run and such. And yeah, we got the quote. So if we go and parse this should kind of convince us that we're indeed running in TDX and everything is set up correctly. This should be signed by Intel or whatever. And yeah, so we got like a camel VM running. So that's the first step, right? And I'll probably stop now for like a minute and see if there's any questions. The next part will be, I'm just gonna go and run Docker inside and see if we can get the code to still work. Is Kabuk a canonical or an Intel team? I have no idea. Kabuk team. Yeah, does anyone know I don't think they're part of canonical because they have a separate PPA, right? It's not the usual canonical things. So I'd be surprised if they were. Yeah, trying to look. Yeah, hard to say. I don't know. I wouldn't be surprised. I wouldn't be surprised either way. All right. I actually have a question here to Mo, because Mo has actually went and parsed this quote. And Mo, could you maybe paste me or paste in the chat the parsed data for this quote?
Yes, I can. 1 second. I need to parse it again, but give me 1 second.
Right. Okay.
Andrew has written a cool script that does exactly that. I think it would be nice to show here.
Yeah, Mo, do you want to show the script, or we'll probably cut you off guard, so I don't want to make you show.
All good. All good. Where should I post the quote? Output?
You can DM me. Maybe I can just show it here.
All right, I'll send it to you. 1 second.
Yeah, but so we have a very nice parsing tool from Andrew. We should definitely go and look at least.
Yeah, the one from Andrew is parser for the version 4 of the TD quote. So basically TDX 1.0, I think. I've written 2 parsers in Rust, which one is v4 and one for the v5 in case we utilize the newest TD quote. So we have 2.
Amazing.
I can share with you the 2 repos. So this is the code parser in Rust. And I'll fetch you the one from Andrew shortly.
All right. Okay, so this is the parsed the parsed quote, and yeah, it looks like everything is here. Yeah, no owner anymore. It's kind of hilarious. Yeah. Intel, I think, dropped the owner, right? Okay, and we have the three, most important measurements, right? This is kind of what we care about, and user data is just zeros, right? We didn't actually post any
Actually,
data.
sorry, I think I misled you here. The RTMR3 is not necessarily user data. It's like an empty field that can be extended with whatever later on, because if you go up, you will see user data. There is a field specifically for user data. Yeah.
Right. So there is some user data.
It was my
The
fault.
The RTMR3 could be used for the bulk private SSH key, for example.
Yes, you can use it for anything you can think of. Like it's a 64 byte, I think, array.
What do you mean by private key? So the public part of the key or something like that?
Yeah. Yes.
So if I want someone to, if I want to convince someone that I'm running in SGX and and give them a way to give me data in a way that only I can get it, I should just put my public key or like a hash of my public key inside this RTMR3, right? And they can encrypt to that, and they can be reasonably sure that if they check that I'm actually generating the private key inside the enclave, right, inside TDX, and they check the other three, so the image and the command line, whatever the boot config. They can be reasonably sure that they can encrypt to that key, and only I can decrypt it inside TDX.
It's like you can think of it as a field where you can export some data to the outside attestably. Like basically, you can make sure that this is really by this image, and you can attest it like it's secure, like it's not being manipulated or maliciously changed.
That's pretty cool. That's pretty cool, actually. Because that's the next step, right? How do I get data in? How do I get convinced that I can get data in, right?
Yeah.
And that would be one way. So that's interesting.
If you notice, like when you generated the TD quote, you got like 3 failures at the end, which says like could not extend those RTMR2 and 3 failed to extend. Yeah, maybe we could look into this later on how we can extend these and add some data to it. But yeah, this is the main idea of the attestation here. You can add stuff.
I see. And with what would we extend this? Because as far as the guide goes, they're saying that this is fine.
Yes,
but
fine.
I'm not sure I trust. And what would happen here?
What would happen here, if I understood correctly from the documentation, that the TD module will inject those values plus their hashes and signs them, and put them part of the attestation report. So this is like mainly, as Frieder said, like you can use it to, like for example, exposing your public key, and you can attest it then through the TD quote, and it will be part of the general hash value. And like a very important part, if you show the parsing again, is the MRTD actually, which is how I interpreted it is basically comparable to the SGX enclave, MR enclave, so the measurement enclave. That's how I understood it actually. So this here is basically measurement TD instead of a measurement enclave. But I also noticed that your image that you created on this machine and the one that we created on Andrew's machine, on 2 different machines, they were generating the same measurement, which is actually correct, because if you think of it, you are both of them, like you and Andrew generated the same image, so like from the same base image. and you didn't do any changes. So I would expect also to have identical value. But
I did use different options for my Camus CMD though.
I don't think this is the case. And if we can get a Yocto attestation, we will likely see the same MRTD. And the reason for that is the MRTD only has like it's the initial measurement. Like if you look at a TPM measurement, PCR0, the first value that's being measured, that's only like the firmware and the boot, UEFI, stuff like that. This is what's being measured. And then you have RTMR0, which is probably the kernel.
yes.
RTMR1 might be the inner drum disk, and RTMR2 kernel command line. But like I don't know which one of these, but that's basically what they're measuring afterwards, which you will find in PCR3. Well, in the PCR values.
Yeah.
So, but MRTD is PCR0. So that's basically that's why it's called MRTD. It's the measurement of the TD itself. So before any VM has happened, it's only the initial trusted domain that's being measured here with a firmware that's then eventually going to boot the VM.
Yeah, makes sense as well. But at the same time, I don't see any usage for it like at the moment for security wise. So basically, the most important
I mean, it's the firmware. It's a boot. It's the UEFI. You need to know what's being booted here. If you don't know what you're booting, you could easily sneak in a backdoor. So this is
of course.
This is part of security.
Yes, but we don't have the access on this firmware. It's proprietary. So basically, you kind of like just trusting this hash to be.
No, I think in this case here, we do have access. This is what we give by the QEMU commands. There's we provide an open source UEFI implementation, and I don't know what else is in past as firmware, but we do have access, and we can actually try to reproduce this MRTD measurement.
This would be an interesting to verify this. Actually, this is nice. But yeah, back to the RTMR0, 1, and 2. Yeah, you are correct about this is the unified kernel image hash, and I think the one was the CMD line and the second is the init disk. But why do they say then that those three values cannot be generated without like booting the image? So these three values are runtime measurements that can be only generated during runtime and cannot be done at compile time, like at building time of the image.
So there's a misunderstanding here. RTMR 0, 1, and 2, these are different depending on the VM image that you're booting. So it might as well be that you're going to boot an image that's not going to send this event of I want to have a measurement right now, and then you don't have any RTMR0. You don't even have an RTMR0, not even like a 1 and 2 out of question. So it depends on whatever you're going to boot, which is then going to give you a measurement or not. It depends on the code that you like. This is a chain. You put in, measure something, you execute that, and then this something is going to execute something else, which is then being measured, and so on. So depending on what you're going to start in the next phase, it's going to give you a measurement or not.
I see.
Yeah, I think that we actually can get this at build time. It's just complex and they didn't do it yet. But if you just captured all those events, I think that you can get this without access to TDX at the least, right?
Definitely, if the MRTD is PCR0, which is what they're saying, then we just need to look at the TPM documentation and look how they're measuring the firmware, and then we can reproduce the MRTD.
The MRTD, yes, but the RTMR
that's for the MRTD. But how about
How do you do them? That's a question.
But I think it's the same for those, right? You just have to emulate it, but there is no, like, those are not signed or anything like that, right? This doesn't require access to TDX hardware.
No, for these measurements, we already have a code that can measure these parts of the disk.
But are they comparable with the same values? This is the question. Like, are they generating the same values as these? We didn't verify this. We have to verify this, in my opinion.
Yeah, sure. We can verify that. We can just run the script on the image that we have here and check whether.
I tried this. It doesn't work out of the box. You have to do some kind of changes because the script does not accept this format.
What is it? Is it the QCOW2 format, something like that?
Yes, it's QCOW2.
Okay, and that's the reason why it's failing?
It's failing. Yeah, it's failing, not necessarily because of the format, but I assume it's because of the format. So I will try to change it to raw format and try again.
Okay, I don't think this is, like, we can fix this. It should be easy.
Yeah, definitely.
All right, amazing. Cool. So last thing, I'll show you how you can access the DX codes inside Docker, which I think is pretty cool. So I'm going to run a privileged container because I have not yet figured out how to run this in user mode. The usual tricks with C groups don't actually work. I'm sure this can be done, just didn't have the time yet. And also not sure if we want to use Docker, so not investing too much. Yeah, let's see if I can get this to work. And what we'll use is the one of the tools from the people. Let me remember actually do this. Oh wait, yeah, okay. So installing the some tools to then add the repo. All right. We are not pinning. I think that this actually okay, is this, yeah, trust authority, okay, and then quote just like that. This is just 0, I think. All right, and we did, get a quote. All right, so this is from inside Docker, which I think is pretty cool. It is running privileged, which is not cool. It's completely broken. But yeah, you can see that we do have a access to the device, and it's generating quotes just fine. I'm actually not sure what this code has, what this code contains. I think it would be pretty cool to go find out. We should definitely go try and parse this. Probably not right now. So if you want answers, you have to reproduce and then check the code. But in the meanwhile, we'll for sure try and parse this and yeah, see what this code has inside. All right, so yeah, we are running Docker in a way that is attestable, right? So if this initial VM was generated reproducibly and you could attest it, and it didn't include SSH access, you could actually be reasonably certain that the way that the containers are run is as you expect, which I think is interesting. And yeah, there is not really anything severely broken, I think, about this approach. Although I'm pretty sure that the code that you're getting inside Docker doesn't actually give you any guarantees about the container running, rather about the initial VM, which could be actually useful in some way. So yeah, I think that's it from me for today. Do we have any last questions? Maybe questions from YouTube, if anyone's is there. Just looking at the comments. I'll go check.
No questions from YouTube, but if you're watching this afterwards on YouTube, please go to the forum, ask your questions in the thread. It's linked in the description. And then any upcoming sessions will also be posted on the forum, collective.flashbots.net. Thank you so much.
All right. Thanks, everyone. And yeah, see you next time.
Awesome.